Now, we are going to look at how do we actually interpret the confidence interval. Well, here you have to be pretty careful with your wording. The correct way to do it, or this is one of the correct ways to do it anyhow, would be to say we are 95% confident that the interval from 0.324 to 0.376 actually contains the true value for the population proportion. Notice, we need to have our confidence level included in here. We need to have our values that we are working with, and then we can add the topic here. So if I wanted to say it contains the true value of the population proportion of registered voters who are likely to vote in our next election, that would probably be even better. But that would obviously change depending on your topic too. Okay, now one thing that you want to avoid saying, and this is a common error, is we do not want to say anything along the lines that there's a 95% chance that, and then you could, insert all the rest of this information here with the values. The reason we don't want to say that there's a 95% chance, because that would indicate that the value of the population proportion is left up to chance, when in reality it's not. It's a single value that's not left up to chance. So we don't want to give any indication that there's a 95% chance or anything like that. So we want to stay away from that phrasing. So if you use the top phrasing, that's going to be your safest and your best bet when you're doing the interpretation of these. They're going to sometimes give you some slight variations of problems like this. So let's say that we heard on the radio there was a 90% confidence interval from 0.743 to 0.779. And I didn't put any topic in here because that's not the important part right now. But this information that they gave us here is enough that we can find the point estimate associated with the information. So one way that you might want to visualize this until you get comfortable with it is if we put these on a number line, our interval, 0.743 to 0.779, and we think about what a confidence interval is. Well, what we did in the other ones was we did p hat, and then we added our margin of error, and then we did p hat, and we subtracted our margin of error. Well, these two values right here are going to be symmetrical because we're going above and below the same amount. So our p hat is going to be right in the middle of our interval. So if we want to find that point estimate, we have to find the middle of the two values that we are given. So in order to do that, we would add our values up, 0.743 plus 0.779, and divide by 2 in order to find the middle of our values. And that ends up giving us 0.761. So our value for p hat here is going to be 0.761. That would have been our point estimate. So whatever sample they took, when they computed the proportion, they ended up with a sample proportion of 0.761. Now the second part to this, it says find the margin of error associated with the information. Couple different ways that we can do this. Since we already have our p hat, our margin of error is the distance from p hat to either one of our n values. So we can just find one of those distances. So we could do 779 and minus our 0.761, and that's one way that we can come up with our margin of error. When we compute that, we get 0.018. So that would be one way we can find our margin of error. The other way we can do it is, since we know that these two distances are the same, well, our total distance from the lower end of our confidence interval to the upper end of our confidence interval is double our margin of error. So if we wanted to, we could find the difference between our lower and our upper ends of our confidence interval, and that would give us how far apart they are, and then we could cut that in half because then that would just give us one of these segments here, and that's still going to produce the exact same margin of error. So it doesn't matter which method you like, they will both produce the exact same results when you're trying to compute the margin of error. Okay, now this last one, I'm not going to go through the entire formula because it's using the exact same values that we had before, but there are going to be times when you will have to determine the sample size that you would need in order to produce a certain margin of error. So you might have a problem that says, what sample size would you need in order to make sure you're off by no more than 100? So what they would be telling you here is that the margin of error was 100. And then they would be asking you to find our n value. So in order to do this, all we actually do is we rearrange this formula right here, and it produces a formula that allows us to find our sample size. So all of these other values here, though, are the same that we would have used earlier. So our z alpha divided by 2, that's our z-score that we get from our critical value. And then the p hat is our population proportion, just like it was before. Q hat is the complement of that. And then the e is our margin of error. Now, there are going to be times when we do not know our p hat value. They just don't tell it to us. In that situation, we're still going to use the same formula, the same setup, but in place of the p hat and q hat, we would just substitute 0.25 in there. And that would give us the best estimate for the sample size we would need if we don't know p hat and q hat. But if we do know our p hat, then you go ahead and use this top formula because it will give you better results.